We are looking for a polar equation today, and we're going to start with a Cartesian equation. X squared plus y squared is equal to 2cy. So we're going to get rid of our x's and our y's, and we are going to add in r's and thetas. So those are the two letters that we want to have. To do this, we're going to need a couple pieces of information. One of them is that r squared is equal to x squared plus y squared. Another equation that is going to be useful for us is x is equal to r cosine of theta. The second one, y is equal to r sine of theta. Now, these are very handy dandy tools that are used very frequently when you are working with polar coordinates. There's another one that we will not be using today. Tangent of theta is equal to x over y. I'll add that on there because you may find that useful in the future for similar problems. So let's start off with our equation. We have x squared plus y squared is equal to 2cy. And as you notice, we have that x squared plus y squared is right here. We also have an x squared plus y squared in one of our equations, so we are going to do a substitution there, and we're going to replace that with r squared. So now we have r squared is equal to 2 times c times y, so we are very close. We just have this y that we have to get rid of, and if we look over on the left-hand side, we'll notice that we have an equation for y. So we can substitute, instead of our y here, we're going to put in r sine of theta. That is going to give us r squared is equal to 2 times c times r sine of theta. We're going to do one last step to kind of clean this up a little bit. We're going to divide both sides by r. So that is going to cancel out the r on the right-hand side and one of the r's on our left-hand side, which is going to leave us with r is equal to 2c sine of theta. So here we have our equation, and we want our polar coordinate equations usually to have r's on one side and thetas on the other side. Thank you for listening.